This is my solution for problems A, B, and C for the first round. We are given n, the number of cards, k, the maximum number of cards that can be combined, and the values of all these n cards. What we want to find is the number of different sums that can be derived from all these combinations of cards, of course with k or less number of cards. So let us just take combinations of cards that are k or less in length. Of course, there is then no guarantee that there is no repeated sum. In such a case, then we must be able to remove the repeated sum. We will now try to find a systematic way of approaching the number of different combinations. Let us start by picking the first card. Well, then we can pick any one of the next few cards that follow as our second card. The third card can then be any of the next few cards that follows our choice of second card. Of course, we can see that if we choose our nth card as the second card, then there can be no other combinations. Well, we can see that this will greatly spiral out of hand sooner or later as all the tree expands and the number of cards increase. Anyway, we want to find the number of different sums. So for each of this expansion, for each branch of the tree, in fact, each node of the tree, we have to find the sum that is equal to and make sure that there are no repeated sums for any of them, or if there are, to remove the extra number of counts. Let us look at a different approach to finding all these combinations. Let's say for a certain number of cards, we have already found all possible combinations. Each combination can be defined in two numbers. First, the sum of the cards, and second, the number of cards being used. Well, let's say we have the next card, 8. Well, we can either choose to not add the number of 8, or we can choose to add 8. In that case, the number of cards used will have increased, and the combination will more or less double. Of course, if we have a combination that can exceed the number of cards being used, then we might as well just delete it. We shall now try to solve the problem of repeated sums. Well, let's say again we have a set of combinations and we want to add the next card 8. Again, we can choose either not to add it or to add it. In the event that two of the sums are the same, are we able to remove one of them from the set? Since this set contains all possible combinations of cards that we had already seen, we can simply add future cards to the set, and adding them to repeated numbers, say 32, does not make much of a difference. You can just add to one of them and you still get the same combination. So which one of the repeated ones do we want to remove? Do we want to remove the one with the larger number of cards or the one with the fewer number of cards? Of course, we remove the larger number of cards because there are more combinations that you can form with the ones with the fewer number of cards. Well, so if we are given a combination of cards, how can we store them? Well, we might think of using an integer array, the index being the sum of the cards and the integer being stored the number of cards used to form that sum. Of course, this might be a problem in cases where the sums are very far apart, in which case the array will be filled mostly with zeros and we are wasting quite a lot of space. And if we want to find the next occurrence of the sum, we will have to look for it after a very long number of zeros, which makes adding things troublesome. So instead, we can use a hash table in which we have a hash function that maps all the large numbers into an array that is of specifically around the same size as that of the number of elements in the set that we are going to store. So each one is at best randomly mapped to a specific index in this hash table. Okay, if our hash function is random, then our numbers will more or less be uniformly distributed over the whole array, and we would be able to easily just iterate through the entire array to get all our numbers in our set. Let us now take a look at the code. First, we have n, which represents the total number of cards. Then we have our hash table, which Java has already implemented for us. We first put 0, 0 into the hash table, which means that the sum of no cards being entered is 0. We will then scan each card individually, and for each card, remember we want to either choose to add it or not to add it into the current solution. Well, first we have to make a copy of our previous solution so that we do not lose any information. And this is given in the next loop. Here I'm storing each sum into the array keys and each card into the array cards. Well, let's remember what we need to do. We need to either choose to add the new card or not to add the new card for each of the current solution that we already have. Okay, so we can look through each of our solution that I had already copied out into my array of keys and cards. And if the number of cards exceed the number k, which is the maximum number of cards I can use, well then I don't really need to care about this solution. For those valid combinations, we want to check if it is a repeated combination. So we store it in this variable called num cards, and if it is null, it means that there is no repetition. This is not a repetition. If it already is repeated, then what we want to do is only store the value if the number of cards for our new solution is smaller than the old solution. Okay, so if it meets the criteria, then we add this new solution inside. So now we already have all these possible combinations. Well, it's simple. All we have to do is print the size of our solution. And we have to remember to subtract the 1 away for the extra 0, 0 combination that we had added.